Hi, I'm Scott Rowe, founder of robotics.com. Robotic systems use electronics and motors for decision-making and motion. Both electronics and motors require electricity. But what is electricity, and how does it work? Simply put, electricity has to do with the movement or buildup of charge. Usually electrons are the charge, but more on that later. It turns out that electricity shares some similarities with the flow of water through a pipe. On the right of the drawing, we have water in a container. The greater the height of the water in the container, the greater the pressure in the tube. The water pressure is similar to electrical pressure, which is called voltage. On the left of the diagram, we have water flowing out of the bottom of the tube. The amount of water flowing out of the tube per unit of time is called the rate of flow. The rate of flow of water is similar to the flow rate of charge in an electrical system. This is called electrical current and is measured in amps. Just above is a restriction in the tube. The greater the restriction, the slower the flow rate. The restriction is similar to electrical resistance and is measured in ohms. The relationship between these three concepts is known as Ohm's law, which states voltage is equal to the current multiplied by the resistance. So let's look at how electricity flows. As we have said, it is the negative charges that make up electrical flow, or current. Let's take a look at an atom. The center or nucleus of the atom contains positively charged particles and particles with no charge at all. The outside of the atom contains the electrons. These orbit the center or nucleus of the atom and are negatively charged. When some electrical pressure or a voltage is applied, the electrons move. They jump from one atom to another, and so on. This raises an interesting point. Some materials are made up of atoms that don't easily give up an electron to a neighboring atom. We call these materials insulators. Good examples of insulators are plastic and glass. Materials that are made up of atoms that freely give up their electrons are called conductors. Good examples of conductors are copper, gold, silver, and aluminum. Let's take a look at a simple circuit. Let's connect a battery to a resistor labeled with a capital R. Current flows from the top or positive terminal of the battery. It continues through the resistor and finally returns to the bottom or negative terminal of the battery. But notice in which direction the current is flowing, from positive to negative. Actually, the electrons, which are negatively charged, are flowing from the negative terminal of the battery back to the positive terminal in the opposite direction of the current. How can this be? Well, it all started with Benjamin Franklin. Back in the 1700s, he said that the charges that were moving were positively charged. This terminology stuck, and it would be many years before researchers would figure out that it was the negative charges that move in circuit. But the scientific community had already produced a large body of data using Franklin's terminology. So we ended up with both of them. Current flows from positive to negative, and the electron flow flows from negative to positive. But for most of your study, current will be the concept most used.